Hello class, in this video I'll be showing you a few formulas for conditional probability and then using those formulas to determine the probability of these three examples that I talked about in the previous video. Let's begin. The conditional probability of event E given event F has already occurred is the following. It is the probability of E and F occurring divided by the probability of F occurring. Now, since we know that F has already occurred, the probability of F is going to be in the denominator. And in this case, and in every case, these two letters will match. And again, that's because we know that F has already occurred, so the probability of F has to go in the denominator. Now, what happens if we're given raw numbers? Well, the probability of E given F has occurred is equal to the number of elements in E and F divided by the number of elements in F. Okay, so now that we have the formulas, let's take a look at the first example. Two fair dice are tossed. What is the probability that the sum of the two dice is 8, given the sum is greater than 7? So in the previous video, I already identified event E and event F, because we want to figure out the probability of E given F. Now we need to know what is E and F. Well, that is the sum is 8 and the sum is greater than 7. And since the chart provides raw numbers, we can find the probability of E given F as the following. It's the number of elements in E and F divided by the number of elements in F. So I will start by determining the number of elements in event F. Here's the chart, and I'm going to highlight all of the pairs where the sum is greater than 7. And it looks like there are 15. So the number of elements in event F is 15. Now I want to know how many of those have a sum that is 8. So let's go back to the chart. Different color. How many of these have a sum of 8? So that's 1, 2, 3, 4, 5. So the probability that the sum is 8 given the sum is greater than 7 is 1/3. Okay, on to example 2. One card is drawn at random from a standard deck of 52 cards. What is the probability the card is a 4 given the card was red? So in the previous video, we already identified event E and event F because we want to find the probability that event E occurred given F already occurred. So now we need to determine what is E and F. Well, that is the event the card is a 4 and red. All right, since the chart gives raw numbers, the probability of E given F is the number of elements in E and F divided by the number of elements in F. So let's go to the chart and figure out how many red cards there are. So if we take a look at this chart, exactly half of the deck is red. So in this case, there's 26 red cards. So the denominator is going to be 26. So out of those 26 red cards, how many of them are 4s? So here's the first row of reds. Here is the second row of reds. And how many of them are 4s? Well, we have a 4 right here and a 4 right there. So there's 2. So the probability the card is a 4 given the card is red is 1/13. Okay, on to the last example. Susan took 2 tests. The probability of her passing both tests is 0.6. The probability of her passing the first test is 0.8. Susan passed the first test. What is the probability that she passed the second test? Okay, so again, we want to find the probability of E given F, and event E and F have already been identified. So E is the event Susan passes the second test. F is the event Susan passed the first test. So what is the intersection E and F? Well, that is Susan passes the second test and passes the first. So the probability of E given F in this case is going to be the probability of E and F divided by the probability of F. And we're given both of those numbers. So the probability of her passing both tests is 0.6. So 0.6 is going to go in the numerator. The probability of her passing the first test is 0.8. So that is going to go in the denominator. So that is equal to 6/8, which is equal to 3/4. So the probability of Susan passing the second test, given she passed the first test, is 3/4, or 75%. And we are done.